Hello everyone and welcome to the first lesson kind of in planning. We're using our first project in this course, the fire pit burner box assembly, to kind of walk through this. So here I have the blueprints. We've got some other detailed blueprints as well, but this one gives you kind of the overview. Unfortunately it's a darker color so it's hard to see. So now we're down here in a wireframe. This is a top view giving us our outside dimension. And then as you can see, we have 8 pieces, 1 base plate, and then our flanges tie in here with weld seams there, and along all these other hidden lines. As we scroll down to this one, we pay attention to this is going to be an outside corner joint full penetration weld, right, as far as the detail goes. And in this situation, it shows like it's a surface pin weld, right? It's not a full joint complete penetration unless you wanted to come back from this side of the weld. If it calls it out, to be able to weld that out. But in this case, we're going to weld from the inside and put a pretty good bead on it there. Okay, this will wreak havoc on distortion if we don't sequence this thing right. So a few of the things we want to do is we want to get it tacked together, usually 2 opposing sides, make our measurement, and then these 2 opposing sides, get them with a light tack. Make sure those measurements are equal as well, and then we can start filling in these other sides as we go. And then when we were to sequence this to keep it from distorting and warping, we might do a couple inches here, a couple inches back in this direction. You could do a center tack on all of them to get started. Get with your instructor when you start in this class and we can walk through a little bit more of how we would sequence weld this to keep the distortion down. Because what essentially we're looking for is a nice flat surface here along the top flange to be able to sit inside of there. Now you can put these burner holes on the bottom side to let some air in. These ones are on the top. And you can change up these patterns any way you want. There's no specific call out on the print for this at all. We just went through a pattern. We did a square pattern and then an extra one out here amongst these sides of the polygon. Okay. All right, so keep this in mind as we're going ahead. What I've done is I've drawn the main parts up of this in AutoCAD, and so I'm going to switch over to my AutoCAD program now, and we're going to look at this. Okay, here's where I brought the drawing file over, and in this case I could save these, copy these to another one, and these would just be my CNC plasma. Save it as a DXF file, and then I could nest it on the computer and it would maximize efficiency and get rid of the dimensions. Okay, naturally if we read this parts list, it gives us all of our dimensions, what we need to do here. This is part A, right? Item A, item B, and item D. Gives us our angles and our dimensions in order to fabricate this piece and draw it out. And then from this parts list diagram, we're able to figure out how many of each one we need, right? 1 for part A, the base piece, part B, which is the sides. We're going to need 8 of those. And then D, we're going to need 4 of them because they cover 2 sides at a time. All right. So as we start talking about the planning and the invoice, which is my next step, let's keep in mind that this CAD work has already kind of been done. And when I did this, I copied and made sure that I had an extra one. I just copied everything. These ones are at a half scale. I could put them back up to a full scale and save them as a DXF file, which is what I have right here. These are full scale, and I could just save this file as a plasma for 1 piece. Okay, and that way when the operator goes to the plasma, they know when they're nesting that we break these pieces out and say, well, I need 1 of this, 8 of this, and 4 of these. Now these usually typically have to be in separate files. Everybody's plasma is a little bit different, and so forth. So let's go to the Excel spreadsheet that we have the students do here on starting out with the planning stage. So basically I want to talk a little bit about a one-off versus a production piece. So the one-off or a custom job where you have to figure all these things out, it's going to take a little bit more time. Okay, so as you can see in here, I start CAD design for fire pit burner assembly, one-off or the first production of this product. Okay. So this is kind of just my header. I don't necessarily need the rate hours in here, but I could put gather material specs, design, put the inlet holes in here, and there's several hours here on the CAD program of doing the first one. When we scroll down here, I want you to do a reproduction run, which is the second production of the fire burner piece. If you notice, there's no CAD work here at all, or there isn't any CAD work here at all, because it's already been done on the one-off. So this is where we start to make up our money. And if you also notice the difference, $11.62 on the first custom job, and then down here, I forgot to put a total at the bottom, we're $450, right, for time and labor coming out of the shop to be able to weld this piece out, versus $1,160. It's over $700 worth of savings. So especially in a small shop, if you keep these files, keep them going, and maybe do a slight modification to them, maybe change the design inside or something else, then you're going to be able to make up a lot of money on the back end instead of all this time on the custom job or a one-off production. So as we go to planning, I want to talk a little bit about detail. Okay, what I don't want to see is did some CAD work over here, putting in like did CAD work, weld and fit together, you know, and then 9 hours. I want a printable invoice that you could give a customer, and a customer always feels better about spending this amount of money on a fire pit, or particularly on a burner box, if you lay out exactly what it is you're doing. And I kept it here to like a 1 hour shop rate minimum. You know, for the first one, definitely. You know, you can get a lot more specific as you need to. You can cut it down into 30 or 45 minutes as we start talking about lean manufacturing, Kaizen system, and so forth. But this is where we're starting, okay? Number one, most of our industry partners in the Treasure Valley here want us to be able to, want you as the student to come out of the second year, be able to fill out an invoice, it's understandable, and be able to justify your work, what you're doing, and turn it into somebody, and they just call the customer or the client and they bill it. If they have to give it to somebody else and they got to come out to the shop floor and spend hours with you discussing, or an hour and a half with you discussing how long did it take, what was it worth, how much time did you spend on that, then there's two people wasting a couple hours, doubling the rate of 4 hours versus you just doing this for one. Okay, so an estimator as well is going to use something very similar to this. And he or she might include some inches of weld, the material. This is specifically just for the labor piece right here, right? So gather material specs and measurements for the assembly. Again, you have to kind of evaluate what you're doing before you even start, right? Figure out how's this thing going to be cut, what size of material do we need, what are the dimensions, what's the accuracy, and then how's it going to be, and how's it going to assemble within another piece. Okay, which we would take, and we could go back to the main body of this section here and know that this has to fit inside of this main body piece. Okay, so we need to know our tolerances, and then how do we get it in and out of here if it's hot and burning ashes, things like that make a big difference, particularly when we're working with our clientele. Okay.